So, last Friday we looked
His
at
parents
quadratic
aren't white.
applications that dealt with Pythagorean theorem. Today we're looking at quadratic applications with geometry. More specifically, rectangles. Only rectangles. Now, when we looked at linear applications, we saw the perimeter of a rectangle, which was adding. Now we want to look at the area of a rectangle because that's going to create our quadratic equations. An area of a rectangle is, of course, length times width.
Multiplication.
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 So before we get into word problems, let's look at how to set up a problem that's already set up for us. So I have my length W, sorry, my width W, my length 120 minus 2W, and it gives me the area, 1800. If I know that the area equals length times width, then how should I set up this problem? A equals 1800. That equals, what is my length? 120 minus 2W times my width, W. Now you're in a dual credit class, so you don't have to worry about the TSI, my K level class, but this is a TSI question all the way. Pretty sure it's on the test. So once I have this set up, 1800 equals 120 minus 2W times W. How should I solve this? Very good. Distribute the W, right? So I get 1800 equals 120 times W is 120W. Negative 2W times W is a negative 2W squared. So now I see I am working with a quadratic. What is our golden rule? What should I do with this quadratic? Very good. Set it equal to 0. Now instead of moving this 1800 over, I'm going to move this whole part over here because I want to try to keep this square positive. Doesn't matter, but I just like to keep squares positive. So moving everything over gives me 2W squared minus 120W plus 1800 equals 0. So we achieved our goal of setting our quadratic equal to 0. Give me a method to solve this quadratic. Graphing. Yeah, it's already graphed. And I see, what is my solution for that quadratic? 30, yes, where it touches the x-axis. 30. So that tells me that W equals 30. And if W equals 30, what is my length? 60, right? Take 30, plug it into here. That's negative 60. 120 minus 60 is 60. So my width is 30, my length is 60. If I multiply these two, I get an area of 1800. So here's how we're going to set up and work all of our word problems here with geometry. Period. Now let's start looking at these word problems and decipher them. The length of a rectangle is 3 inches more than its width. Its area is 130 square inches. Find the width and the length of the rectangle. Now, which of these terms am I going to write in relation to one another? Am I going to have just a W or an L? A W. So if I'm calling this my width, how can I write length in terms of width? W plus 3. Okay, you should always go back and double check to make sure it makes sense. The length of a rectangle is 3 inches more than the width. And the width is W. So very good. And now I'm given that the area is 130. All right, now I have all the information I need to set up my equation. So tell me, how does this equation set up? 130 equals W
plus 3, or W and W plus 3.
Yeah, either way. So W plus 3 times W, or you can write it this way. And it's going to be solved just the exact same way.
W squared.
So yeah, now distribute the W. 130 equals W squared plus 3W. What should you do with all quadratics? Set it to 0. So this time I'm going to move this side over because my square is already positive. So that gives me 0 equals 2w squared plus 3w minus 130. All right, there's my quadratic. It's equal to 0. How should I solve it? Graph it. I'll give you a hint. With all of these applications, you should probably just graph it, because they're going to come out nice and easy. Because it doesn't make sense to have a length that's an imaginary number, does it? So you know you're not going to be using the quadratic formula or completing the square. That's going to be your method for solving. So as I scroll over here, I see I have x-intercepts at negative 13 and 10. One of these I should throw away. Which one? Negative 13, why? Because negative. Because we're working with distance, right? Or direction. You know you're not going to have a negative number. So throw that away. The only one I'm going to accept is a 10. So W equals 10. And if W equals 10, what does the length equal? 13. So my width is 10, my length is 13, and it gives me an area of 130 square inches. Not so bad, right? Should be a little bit easier than the Pythagorean theorem Friday. Let me give you a couple minutes. Let me have you solve this one on your own.
You're stupid.
The length of a rectangle is 1 less than twice the width. The area is 45 square centimeters. Find the dimensions. So if my width is W, what is my length?
2w.
Very good. 2W minus 1. Again, check to make sure it makes sense. My length of a rectangle is 1 less
Oh, okay.
than twice the width. Looks good. And my area is 45.
Okay.
So I have enough information to solve this. How does my equation set up?
2w minus 1.
Okay, 2W minus 1. What's the rest of it? Times W equals 45. Now, distribute across here. So 2W squared minus W equals 45. Since we're dealing with quadratics, what should I do?
Oh, set equal to 0.
Very nice. Set equal to 0.
Okay.
So subtract that 45 across, it equals to 0. And then with all of our word problems, we want to solve it by graphing. So as I look at my graph here,
Oh, so you just, oh, okay.
I have 0 at negative 4.5. I'll throw it away because this is negative. And 5.
5 and 0.
So my W equals 5.
5.
Therefore, my length equals what? 9. How did you get 9?
Because it's 2 times 5 minus
Yeah,
1.
plug it into here. 2 times 5 is 10, minus 1 is a 9.